One of the main issues with my custom blade controller for Galaxy's Edge lightsaber blades, which this is one of them, has been that I want to be able to provide instructions on how to make one yourself and include a list of where you can get all the resources necessary. And some of these chips, like the microcontroller and the voltage regulator, they're a little bit hard to come by right now. It's just a supply chain issue right now. There's nothing I can do about that. But there's been another problem, or another component, another thing that I haven't been able to find a suitable source for. And it's something like this. This is a POGO pin adapter. You have pins here, 2 rows of 3 pins here, and you have 2 rows of 3 pins, 3 POGO pins here. And they're spring-loaded, so you can press down and make a connection with whatever you're trying to program, such as, or connect to, I should say, such as this programming header here on my custom board. And the idea is you would press the pins down like so, and because they're springy, you can press down a little bit, and if you're at a weird angle, if you're not perfectly straight on, that's okay. Some pins will compress more than others, ensuring that you've got good connection across all the pins. Now, this adapter I got off of Tindy. Not long after, maybe no more than a month later, they were out of stock, and they haven't been in stock since, and that was over a year ago now. And so now, as people start trying to build their own custom blade controller, they're asking, okay, where can I get one of these POGO pin adapters so I can program the board? And I don't have a good answer. You could look on Tindy. The store that has these is still there, and there you can be put on a wait list. I don't know if they'll ever be made again or not. So I've done something which I should have done a long time ago, and I don't know why I didn't. But that is to go and design my own version, my own PCB that you can then assemble and get your own POGO pin adapter. I did take some keys from the things that I liked about this one. I like these little indentations here for your fingers so you can hold it down, so I included those here. But I brought them forward a little bit so you have better, what I feel is better control over aiming where the pins go. I've also made it a little bit bigger, a little bit longer. I did include a little pin out here on the top, similar to what they have here. This is like a standard for in-circuit programming ports for, I think usually Atmel or AVR, I guess is the correct term, AVR microcontrollers. Because originally I was using an ATmega 328P, but I have since switched to a different microcontroller that uses a different setup. You don't actually need 6 pins, you only actually need 3 pins, but I've maintained all 6 pins because the other pins I can put serial port stuff on it, so I can send debug messages out and attach this and collect those debug messages if I ever need to for whatever reason. So the plan was to assemble one of these. The POGO pins are very easy to come by. They're on Amazon. They're 0.68 millimeter diameter POGO pins. And you might find some that have different tips than others, and you can pick whatever style tip POGO pin you want. For example, these have the one on the POGO pin adapter I've been using has, can we see that there? Sort of like a flared tip there. It's sort of blunt and a little bit flared there. What I've wound up going with, though, is something that has a much sharper tip just to get into the holes on the pads here a little bit easier and help make alignment a little bit easier. So this is one of my POGO pin adapter boards, and it's been populated, and you can see it just goes in like that. And that's the idea. Now you can use this to program your microcontroller on the custom blade controller here. This video is not about programming the board, though. It's about the adapter, the POGO pin adapter, which I'm going to assemble one now and show you how I assembled it. Because these pins are so close together and so small, there's not a lot of exposed copper around the holes. You can see there's tons of copper around those holes, but around these holes, not very much, because I don't have a lot of space. What I perhaps should have done is created like a custom pad for these holes that extended out one side, so you had a larger area to bring in your soldering iron. But in this case, I'm not using a soldering iron. When I assembled this, I wasn't sure how to do it exactly, and what I wound up doing is using some solder paste and hot air, which is what I'm going to do on this video. I have some POGO pins here that I used from a previous project, so that's why I chose that 0.68 diameter POGO pin. Plus, it seems to be what the other one that I was using was also utilizing. And you can get these on Amazon or eBay. This is a package of 100 and it costs about $8. And I'm going to need 6, so I'm just going to grab a few and put them off to the side. I have this silicone mat here, has some area to put different components. And this is one case where this is really useful. Alright, so I've got 6 POGO pins. Now the other thing I need to worry about are the header pins, which is what is going to connect to your programmer. They connect here. You have lots of options here. These are just standard DuPont headers. See, here's a 2x3 female connector, and you can just count 3 in and then cut through the 4th one with some side cutters, and that will give you your 2x3. You have male pins that go straight up like that, and then you have male pins that go at a right angle. I believe there are also right angle female pins, but I don't have those for demonstration purposes right now. In my other one, the one that I've already assembled, I use these, and I'm going to use these again. I like having the wires come out the side so they go under my hand while I'm programming it. They're not sticking up and getting in my face and blocking my view or anything. And these header pins, these are not anything special. You can buy boxes of these on Amazon or eBay for not much money. You can get a whole set of different types for like $5-10. And to cut them, you'll see between each pin there's like a little divot there. You just grab your side cutters and rest them on that little divot there, and then crunch down and you'll get the cut. No problem. So put that off to the side as well. Now comes the fun part: how to assemble this. This is something that I still don't have a full grasp on, but here's what I came up with. I'm going to bring in a ceramic tile. The main reason I want the ceramic tile, well, there's 2 reasons. One, I'm going to use hot air. I want to help protect the work surface. The silicone mat will do that. This will also help. The other reason is I want a hard, flat surface, so when I'm aligning the pins in the PCB, I don't want them to be off a little bit, and this sort of chewy, squishy silicone mat might do that. So it probably wouldn't. It'd probably be fine. I mean, the POGO pins have a lot of movement. They have like a half a centimeter of movement. So if they're off a little bit, it's not a big deal. So maybe I'm overthinking things here. But I've got my ceramic tile here. And then here's the tricky thing. How high do these pins need to stick up out of the PCB? And the answer is it's entirely up to you. I want them to stick down a ways so I can get in there, and so I have some room, but I like having them stick up a little bit just so I can get my soldering iron or whatever on them. So what I've decided I want to do is I want to find something that's good with heat. This plastic is definitely not that. I'm using this for demonstration purposes. That I can then lay the PCB on and have the edge dangling off, and these POGO pins will be resting against the ceramic tile, and that's how I'm going to vertically align the pins. And how high off the ceramic tile you need is entirely up to you, depending on how high you want those pins to stick out. For mine, what I've actually used is something I bought a long time ago as a goof. And now it's proving to come in handy here, which is this. It is literally just a big old block of copper. Now, I don't expect anybody to have one of these, but it actually, the height-wise, it's not bad. The POGO pins stick up just a little bit. Let me get you an angle from the side. You can see the POGO pins stick up a little bit, but not too much. It's exactly what I want. It's the perfect height for me. So that's what I'm going with. Other options is maybe you grab a couple more ceramic tiles, and maybe you have 2 ceramic tiles and you dangle them off the side and you use a silicone mat beneath that. like this to two tiles, and that would be about the right size too. The goal is, it doesn't matter what you use as long as to hold the PCB, just as long as it's sturdy, it's not going to go anywhere, and that it's heat resistant, because I'm going to be using hot air. So this is a big copper block. All it's going to do is conduct the heat away. Now it's really just a matter of putting in the POGO pins, applying some solder paste, heating this up. The solder will flow, but what's inevitably going to happen is that I'm going to have too much solder paste, and there's going to be like a blob of solder in the middle connecting all of those pins, which is what happened when I assembled this the first time. And my solution for that is, while I had hot air heating up the pins and keeping the solder molten, I came in with this. This is a solder sucker, and no solvents or heat. But the tip here is durable against heat. The way the solder sucker works is you push this plunger down, and then it clicks into place, and then when you press this button, the plunger shoots back up using a spring that's inside here, and when it shoots back up, it creates a vacuum that draws stuff into the tip here, like that. So it sucks up whatever you're pointing at, solder in this case. Okay, so first step is I am going to tape the PCB down just to keep it from moving. The copper has such weight to it that I'm not worried about the copper really moving around all that much. Now the thickness of the PCB should be enough to keep the pins themselves straight. If the pins aren't perfectly straight, but if they're just a tiny little bit off, that's okay. You could use these, you could insert these with tweezers. That's probably the better approach. You risk bending them if you push too hard, so I'm trying to gently wiggle and push down at the same time to try and get them to fall into place. So that looks okay. I'm just going to inspect it from the side, from the front. If anything looks a little weird, I can just tap it with the tweezers. Everything looks okay. So now I'm going to apply some solder paste. I got this Chip Quick leaded solder here. 63% tin, 37% lead. Squirt a little bit around. And I can sort of already tell that this is going to be way too much, but again, that's okay. The solder sucker will help. I'm also going to apply some extra flux here. It's this Chip Quick SMD 291. Just going to put a dollop or two over it, like that. And it's real viscous right now, but as it heats up, it's gonna flow more easily. There we go. Okay, I've got my hot air reflow station here off to the side. It's going to be set to about 350 degrees C. This board's not going to see that kind of temperature because the air is going to cool as it's leaving the nozzle. And what I want to do here is I want to sort of bring the hot air all the way around, just even it out, because the solder paste and the flux are going to want to flow, and I want to make sure it's everywhere, all around the pins. And eventually it'll warm up enough that it'll start to flow. The solder will start to flow. There's the solder flowing. Keep the heat on. There's definitely a hole there, or a short there. I've got my solder sucker ready to go. I'm going to switch hands here, keeping heat. I'm going to come in here and try to suck up the excess solder. I'm trying to apply a little extra heat here so it's still hot when I come in here, and I don't think that did anything. Recharge the solder sucker. Did that do it? No, it did not. What worked the first time doesn't want to work this time. Alright. This isn't working to the soldering iron. come in between the pins, heat it up for a few seconds, bring in the solder sucker, and go right from above. I don't see any solder between the pins. The pins themselves look to be good. If I hold this down and press with my finger, I see them staying in place. You can see how maybe one is a little bit taller than the others. That is perfectly fine, just as long as they all are relatively close together. A quick close-up inspection. I can see silver around the pins, so the solder has gone up the pins. Good. That will help with making a solid mechanical connection. I don't think I see any shorts, any connections in between the pins. That looks pretty good. But we'll find out for certain when we test those pads there. Okay, so I have my multimeter probes. They're on continuity, which means it's going to beep anytime that there's a short between the probes. Okay, so I'm going to grab this pin here in this bottom left. And I'll test all the other pins. Alright, the middle one. That looks like a good board to me, no shorts. Okay, so all that's left now is to put the header pin on it, like so. And I'll just solder one corner, make sure everything's aligned, solder the other corner, confirm everything is still aligned, then I'll solder the other pins. There's the solder. Looks pretty good. Alright, so the next thing that I'm going to do is just do a test fit. I'm gonna grab one of my blade controller PCBs and just see if those pins line up well. Give it a little wiggle so the pins sort of go around the pad, and then eventually the tip will fall into the via there. And I've got a really good connection. So that looks okay. The alignment might not be perfect. You can see the pin on the top there is maybe a little bit longer than the others. But that is okay. It does not have to be perfect. That's why we use spring-loaded pins. So if one's a little bit longer, that's okay. We just press down and all of them will make connection to the pads. So I think that is a good programmer, and now I can test it. Alright, so let's try this. Let's test it out. I'm going to hit upload on the Arduino IDE, and while it's compiling the sketch, I'm going to come in here and make contact with those pads, press down, and it is already writing. It's reading it back. It is done. I just got a good program. So there we go. I now have two POGO pin adapters here to program my microcontroller. And you can make one too. Link to the OSHPark project will be down below, along with some suggested links on Amazon where you can get the POGO pins and the headers, but those Amazon links will probably only work for like a couple of months, and then they'll probably not work anymore. So really, all you have to do is search for a 0.68 POGO pin, and you'll find a 0.68 millimeter diameter POGO pins with various different tips on them. You pick whatever tip you like and buy them, and that will be all you need for this. Well, you'll need the header pins too to connect to the programmer like this, but those are very standard, and those will always be available. And now we don't have to worry about POGO adapters going out of stock anymore, because now we have a PCB on OSHPark that we can buy and assemble to make one whenever we need one. Cool. Okay, bonus footage. I'm going to try and solder this one without solder paste, just the iron. I'm going to bring in a bunch of flux here. My plan here is going to be to pre-tin the tip with a bit of solder here, and then bring that blob of solder over, And normally you're not supposed to do this because in the time it takes the soldering iron to reach whatever you're soldering, you lose the flux in it. But I got extra flux on the board, which is why that should be okay. Let's see how this goes. I'm going to sweep this around a little bit so I can come at these pins from a slightly better angle. As you can see that there is a blob right there. I'm going to try and dab, hopefully get a little solder to wick onto the tip of the iron, and then scrape it off. I'm also doing this purposely without the solder sucker because some people won't have one. Doing this without solder paste because some people won't have solder paste. I just want to see if it's doable. Flux is definitely the key. There's really no such thing as too little flux. I think that might have it done. So I think I've got it. The pins aren't perfect, but that's okay. If I push on them, nothing's moving, so I think I've got a good connection. I'm going to clean the flux off, but I don't see any shorts there. And then maybe one of these pins that's a little wonky I can bend into place. The board's been cleaned up, I've added the header, and I've tested it, and it works. The one pin that's a little low, well, it's a little low for a reason. Look at that. That one pin is lower than the others. But because of the POGO pins, it'll still work. Now, I might go back and try to fix that, but to be honest, I don't think it's worth the effort because it'll work. After I cleaned up the initial round of flux, I did find a bridge between these two pins at the bottom here. Added more flux, went back in with the iron, had the solder flow, took the iron away, scraped it off, went back in, did that like 6 or 7 times to every time a little bit of solder wicks away onto the iron, scrape it off, bring the iron back, keep doing that. That's a tedious but effective way to remove excess solder from stuff like this. So there you go. It is possible to assemble one of these with just an iron. You do not need solder paste or a hot air reflow station, although maybe it's a little bit easier, but it's definitely doable. Cool. Now I have 3 of these ready to go. Double extra bonus footage. Since I assembled these with a soldering iron, I saw how difficult it was. I did go back and modify this PCB so that the pads for the POGO pins extend out a little bit. That'll give you a place to put your soldering iron to help transfer heat to the pad along with the pin. So in theory you could solder this a little bit easier with just traditional iron and a roll of solder. I will include a link to what I'll call it as the version 2 of this board. I'll add a link to it in the description of the version 1 board, so you can pick which one you want. The one that I showed assembling on the video, or the newer one, which the only difference again is the pads have been extended out a little bit. I don't have those yet. Those are in order. I won't have those for probably a couple of weeks, but I want to get this video out now, so I can't show you me soldering one of those newer ones together, which is why I'm going to link to this version. Another thing, when I was assembling this, and even before then, I did notice that the top of the POGO pins have holes in them, and I just thought, that's just the way they're made.
I think that hole extends all the way down. And remember when I was covering these in flux? I think some flux went down into the holes, and what happened is a day later, overnight, the pins got really stiff. They lost their springiness because I think flux got in here and started gumming up the springs. So to fix that, what I had to do, and this happened for all three of these, what I wound up doing is I took this. This is a little plastic shot glass. You can buy like a pack of 20 or something from the dollar store. And I took a little bit of isopropyl alcohol and just filled the glass, not too high up, just about there. And took one of the adapters that were a bit not springy but more stiff. And what I did is I dipped them in, pogo side down into the cup here, and I would press the pins into the side of the shot glass here to sort of work the pins while also getting some isopropyl alcohol in here. And then I sort of let them sit there for a couple hours. Just let the IPA have a chance to get into the pins and help dilute that flux. And then I'd come back maybe every 10-15 minutes, sort of, work the pins a little bit more and leave it in there. And it took a couple of applications of that, but it seems like these pins now are freed up and they don't get stiff or gummed up overnight anymore. But that's another thing to look out for. So maybe don't apply as much flux as I did. I may have overdone it. I have seen some pogo pins that don't have the holes on the top. The holes are filled in. Maybe if you find some in the 0.68 millimeter diameter size that you need for this board, go with those. Or if you do what I did, I should say, again, just little shot glass or some other glass, fill it up with a little bit of isopropyl alcohol, something that's not too big so you're not wasting a lot of IPA. Just stick your board in there, work the pins a little bit, let it soak, work the pins a little bit more, let it soak a little bit more, so on and so forth, and eventually everything will clean itself up and you'll have a perfectly serviceable pogo pin adapter with which to program your blade controller, or anything else for that matter. I think that's covering everything about the pogo pin adapter. Again, I've been using this for a little while now and it works. I'm happy with it. The newer version of the board, I've ordered a set of those boards, and I've also ordered some different pogo pins just to try things out, just to see what works. And if there's anything interesting there, I will share an update about that. But otherwise, that's it. This, in theory, is the last piece to making your own custom blade controller and programming it. So really all that's left now to do is a set of videos showing you how to build and assemble and attach one of these. Stay tuned.